Ethan, you're wrong. You were in my room.
Oh, I'm sorry.
So
I didn't even log out. Hold on.
That's what I had to do was power it off. Just now.
Mr. Brand, you were a helper yesterday?
I was a room supervisor. I got to supervise a whole room.
Wow.
And I had help for the 15 kids that were in there, which I have no idea why. But anyway.
More than 10, you gotta have 2 people.
No, see, that's not true because if you proctor it on a Saturday, you can have up to 90 people with one person.
What? Yeah.
So the school district just puts 2 people in there so that we seem busier. So
that had more marbles. I would say my room supervisor knew nothing.
no. It is not that difficult. It is not that hard. They give you a script that you read. You go through it. But again, as me and Miss Morley pointed out, you guys are lucky.
I love it.
You get the test for free.
Yeah.
You get it at school. And you get part of a day off. When we had to take the ACT, you had to pay $100. If you were lucky, you could get in at a local place. Like for us, it was to go out to UWGB. And you had to do it on a Saturday morning at 8 a.m.
And be there by like 7:30
yes.
So you could get in for 8 a.m.
Correct. So,
Mr. Brand,
yes.
was college more cheaper back then?
Was college what?
More cheaper back then?
Oh, yes, by far.
Yes. Why are you complaining? You gotta pay $100 and then with us, yes.
Okay, do you have a job, Kayana?
Yeah.
Where do you work?
What job do you market?
And how much do you make?
$12 an hour.
How much?
$12 an hour.
When I started working, when I started working in a factory in 1989, in a factory, I made $4.75 an hour.
Yeah. I said when I started working, I made $6. Well,
and I had to work from 11 o'clock at night until 7 in the morning. Things are different now. I completely understand that. Completely understand that. But again, you guys do have an advantage. Somehow the ACT board convinced the state of Wisconsin that they should use this as a way of measuring how you guys are doing at school. So because they did that, they were then able to say, okay, every kid should take the ACT, which every kid never used to. And the best part is they convinced the school districts in Wisconsin to pay for you taking the test. So the ACT still gets their money. They don't have to send anybody out to run it. All they do is grade the test and collect the cash. They have a very good deal. So.
You guys get refunded for that.
Well, we can't because of the fact that Wisconsin has now built that into being part of how we evaluate how well schools are doing. So that's why it's important that you do well on the ACT because literally it comes back on what they call our school report card and says, how is East High doing as a school? So.
My ACT probably wasn't that good.
Well, hopefully it was, but who knows? And if it wasn't, well, we'll get through it either way, ladies and gentlemen. So I'm glad you're done with it. I'm glad it's over. If you didn't do it, they are going to be calling you down at some point and having you do it.
And if you didn't finish, they'll be calling you down.
Correct, because if we don't test so many of the students, we get deducted on our report card. So it's all right. We'll get through it. It's happened for years. It'll happen continuously from now. So things will all work out in the end, ladies and gentlemen. All right.
And you just need to do the calculation and the question.
Well, that was what you were supposed to have done for today.
Yeah, you're supposed to have calculations done for
I
today.
know. I was doing my other classwork done doing academic lab.
Well, you should have put mine in front.
Or you needed to do it at home.
There is this thing called homework, and it is possible to do at a place other than at school. All right, ladies and gentlemen, we are going to get you ready we are going to give you some time today, not as much as some of you may need. We're going to give you some time to finish up your lab today. But to start out, can you please log into joinpd.com so that we can do a little Pear Deck with some reviewing? What?
Just wait.
Hold on a second, Zoe. Let me get people logged into that first, and then I will give you the code in just a second, okay? So give me just a minute, Zoe. Hang on.
Shoot, ready? It did say everything. Wow. I see how it is now.
All right.
It'll let me know when.
All right. So there is your code WJUDFF. Good morning.
They mean nothing.
Warm Jacks, usually dry, fragrant flashlight.
What?
Warm Jacks, usually dry, fragrant flashlights.
I wonder what the fragrant flashlights smell like.
Like a candle, probably.
Like a what?
Probably like a candle.
A fragrant.
Yeah, but what does the candle smell like? A candle could smell like anything.
Any flavor candle you want.
Just say it.
Any scent you want.
Give me that hard.
You're thinking of drive in the terms of a car. Maybe it's a different kind of drive.
I guess, like.
I don't know how else you could drive a fragrant flashlight, but well, again, it is what it is. By the way, ladies and gentlemen, just so that you are aware, you will have a quiz on Friday. Your quiz will involve doing a calculation like you are doing in your lab. And then it will involve the relationships that are in energy, mass, change in temp. Those three. So in other words, if you increase the amount of energy you add, what happens to the amount of change in temperature? If the mass increases, what happens to the change in temperature if the same amount of energy is added? Those kind of things. So that table that we talked about the other day, that's what it will be on, ladies and gentlemen. All right, so here we go, ladies and gentlemen. Again, please put your phones away, put your headphones away off your desk, out of sight, out of mind, so that we can get going today. All right, so our first question today is this, ladies and gentlemen. Which of the following contains no energy? Pizza, vegetables, candy, or water? Which of the following would contain no energy, ladies and gentlemen?
Can I put my dot on the word no?
You have a what?
Can I put my dot on the word no?
No. All right, you can, but then move it to the right answer afterwards.
Oh, okay.
All right, so what's the correct answer, Kiana? Which one do you think?
Water.
Okay. Why water, Ethan? Well, you look surprised. What did you put your answer on?
Pizza.
You put your answer on
No
pizza.
energy?
Pizza has no calories, no energy in it.
Oh, no, never mind.
Oh, duh.
Well, because remember, what's the only way you can have no energy?
No calories.
Okay, no calories. So which of these things has no calories?
Ah.
Water. Water has no calories. Okay? Now, again, that type of question is a question where you've got to put a couple things together. Number one, what does it mean to have no energy? It means there are no calories in something. Because calories measures how much energy there is. So again, does pizza have calories? Yes, I had it for breakfast this morning. I had pizza for breakfast this
Did he
morning.
have
What's the
breakfast
matter?
pizza?
Oh, heck no. I had pepperoni pizza for breakfast this morning. Okay? Vegetables do have calories. Some more than others, but again, they have calories. Candy has calories. Yes, water does not. Okay? Water does not. So, which food contains no energy? Water. A food high in calories. Now, please look at your choices. Because again, the question, unless you look at all four choices, you may not be able to figure out which one it is. Okay? A food high in calories, only one of those answers is the correct answer. Actually, two of them might be, but only one is always the correct answer. A food with high calories may taste good. It may not, though.
Will supply little energy.
Well, let's see if that's what you put. Yep, congratulations. You put that one down. Good job, Ethan. Everybody else would put supply a lot of energy. Why? High calories means a lot of energy. That is what we mean by that term. High calories means it will supply a lot of energy. Okay? What kind of temperature change would it create? A larger temperature change. A larger temperature change, ladies and gentlemen. All right? The longer the food or the longer a food burns. So you've got your macadamia nut. It's burning. The longer it burns, which of the following would be true? Please read them all very carefully. Think about them. The longer the food burns, which of the following would be true?
The more mass it will have.
Okay, so tell me that's going to happen the longer the food burns. Now, let's think about this in terms of our lab the other day. So, we needed the mass of the water, correct?
Yeah.
We need a change in temp of the water. The change in temp of the water was determined by how much what was released? Energy. Very good. And then finally, what is going to happen to any object as it burns? It's going to lose mass. Okay? So those are the things that happen when you burn a food. Number one, it's going to cause a greater change in temperature. Number two, it's going to give off more energy. But number three, there's going to be less mass of it left when you are done. Now, the only thing that doesn't get affected by the food burning is how much water was in the can. That doesn't change. That is constant. So, of these four, the more mass it will have. Well, it can't have more mass because if it's burning, its mass has to go down. We said that. Okay? The higher the water temperature will be. That is true. The higher the water the temperature will be, the longer the food burns. Why? Because it's going to give off more energy or more heat as it's burning. The more energy it will have left inside of it. Well, that's not true because where's that energy going? Out into the environment. Very good. The lower the water temperature will be. So the only correct answer here, ladies and gentlemen, is the higher the water temp will be. I got to get back on my page here. There we go. The higher the water temperature will be. Question. Again, not asking you things directly, but making you put the little pieces together that we are learning. Okay? Again, the same question. The longer a food burns, but now you've got 4 different choices. So please take a look at those 4 choices and move your cursor onto the correct one or the one that you believe is correct. But think about what we just said as well, ladies and gentlemen. Okay, what are the difference between the answers that are on the left and the answers that are on the right?
One of them is releasing and one of them is absorbing.
Okay, so what does it mean to release energy, Mariana? To let it go. And what would it mean to absorb it, Jimena? To gain it or take it in. Okay? If you held something in your hand that was absorbing energy, how would it feel?
Cold.
It would feel cold. Think about holding an ice cube in your hand. That ice cube is going to absorb energy from your hand, leaving your hand feeling cold. Why? Because it's taking energy from your hand and going into the ice cube. Okay? Now, if something releases energy, how would that feel in your hand? That would feel hot. Okay? That would feel hot because it is giving off energy. Okay. So, first of all, food burning, giving off or absorbing energy, releasing or absorbing. Come on, that's not the hard question of the day. Releasing. Longer it burns, more or less calories? More. The more calories it will release, ladies and gentlemen. Good. Questions? By the way, what kind of relationship would this be? Why?
Because
The more it burns, the more energy.
Correct. I'm agreeing with you, but that doesn't describe why it's a direct relationship. What happens in a direct relationship, ladies and gentlemen? You are correct, but it's a little bit more specific than that. In a direct relationship, your variables are going in what direction? Thank you. In the same direction. In other words, the time burning is going up, the calories going up, the calories released go up. That is a direct relationship. What is an inverse relationship? The opposite. One is increasing, one is decreasing. Again, conceptual chemistry. We take a lot of the math out of it. Not all of the math, but a lot of the math out. So we'll look at relationships. And the two basic types of relationships we will look at are inverse and direct. Either both variables are going in the same direction, increasing, decreasing, things like that, or they're going in opposite direction. Okay? So very good, ladies and gentlemen. Questions? All right, take out your lab, ladies and gentlemen. Get next to your lab partner from the other day, and let's talk about this. Who worked with Alexa the other day? Okay, I'm going to put the results from yours into hers for the few trials that she didn't get done, just so you know. Okay, so sorry, you're on your own right now then. All right, here we go. All right. Again, are you sitting next to the person who you worked with? If not, please get up and move so that you can be with them, so that you can go through this, ladies and gentlemen.
I mean, I was working with Amena too.
Well, you can go with Humana right now then, because Alexa's not going to be here today. She's not coming in late. She's just not here. Okay. So taking a look at this, ladies and gentlemen, one of the things that I want you to go back through and make sure that you have done, these measurements, mass of the can in the water. You should have your numbers in there, but you also need units with them. What units are there for masses always? Grams. Every mass, every one in blue, every one in brown has to have a unit of grams after it. What is our change in temperature or our temperatures in what units?
Celsius.
Degrees Celsius. Again, if you want to make a degree Celsius sign, there are two ways that you can do it, ladies and gentlemen. When you are in the box, you can hit Control and the period key. That will make a superscript. Type in a lowercase letter O. Hit Control and the period key, and then type in a capital C. That will make the degree Celsius sign for you. Then what I would do is I would simply copy it and paste it where you need it. Go ahead.
What did you do?
Control period key. Type in a lowercase o. Control period key. Type in a capital C. The control period puts you in superscript mode, then takes you out of it. So that our O becomes what we call a superscript, like a degree symbol. Okay? Now again, just so you know, the second way you can do it, ladies and gentlemen, is to go up to Insert, Special Character. Now there are all kinds of things in here, ladies and gentlemen. You see a bunch of arrows and things, but there are all kinds of choices that you have. The easiest thing to do, ladies and gentlemen, is one of two things. Either search by keyword or draw the symbol kind of in here. Now, drawing the symbol isn't easy with your mouse and your keypads and things like that. However, if you can kind of do it, it doesn't have to be perfect, and it will find it for you. Okay? it will find something close to it. So here's the degree Celsius symbol. Okay? You could also start by typing in keyword degree, and it'll bring up Celsius and Fahrenheit for you, and then you could put it in as well. Okay? So again, either way, ladies and gentlemen, will work to put it in there, and then you can copy it and paste it where you need to. Questions? All right. So, by the way, it is very disappointing to me, and it isn't just this class, it is even my regular chemistry class. It is not hard to make observations. What you see, what you hear, what you feel, what you smell. This lab, you got lucky. You could smell things. You could feel the heat given off. You could see the flames. You could see what was happening to the marshmallow or the chip or the macadamia nut as it burned. Afterwards, you could describe how it looked, how different it was, colors, shapes, textures. It was crunchy, things like that. These should be no problem for you. And when people miss these, it is kind of disappointing to me because all you need to do is take 3 observations. That's it. Just take your 3 observations. So make sure you have those done there, ladies and gentlemen. Make sure you have all of this done. By the way, if you don't have something in all 6 of those boxes going down for trial 1 and trial 2, I'm not giving you your point. Now, I know it's just 1 point, but you also need it later on when you do your calculations. Okay? All right. After every set, there's a place where you can do your calculations, ladies and gentlemen. Or I shouldn't say after every set, but after all of the data is collected. So yes, you got to take and re-put your numbers in here. You know what? You can copy them from up here and paste them in here. Just make sure you get them in the right place because I flip-flopped them here. Why? So that the bigger number was on top, the littler number was on the bottom, so that you could just subtract it. I flip-flopped these because the final temp is bigger than the initial temp. Now you're asking, well, why didn't you flip-flop them in your table? Well, because I wrote them down in the table in the order that we took them. So that's why they're different here. And then even the one, ladies and gentlemen, with the mass of food. Now this one, they were actually in the right order because we take the mass before burning, then we took the mass after burning. The mass after burning has to get less. We take and we put it in there. This is the formula that you are going to use today. This is the formula that you're going to use on your quiz on Friday. I will tell you this. I give you this formula on your quiz. You don't have to write it on your periodic table. Now, if you don't understand what it means and you need to make some notes on this, please go ahead. But I give you this exact formula on your quiz on Friday. Okay? So, we are going to take the mass of water times the change in temp of water. That is the 2 numbers that were up above. And then we are going to divide it by the mass of food burned times 1,000. Now, very important, ladies and gentlemen. This whole thing on the bottom needs to be in a set of parentheses, ladies and gentlemen. Now, I put parentheses here and here to indicate these are 2 different measurements. But you're just multiplying these numbers together. You do not have to put these in parentheses in your calculator. You can take this number times this number, no parentheses needed. But before you hit divided by, or after you hit divided by, and before you punch in these numbers, they do need to be in one whole set of parentheses. So don't just put this number in parentheses times 1,000. It will not work. The whole thing needs to be in parentheses. Okay? Now again, the numbers that you're getting should be anywhere from in the tenths to probably in the ones place. Okay? Maybe something that burned real low like the macadamia nut, maybe you get into 10 calories per gram, but I doubt it. Most things are going to either be in the ones place or in the tenths when you're doing your calculation. Okay? Do the 2 calculations, and then, ladies and gentlemen, we average the 2 numbers together. Now again, this is just mathematics, ladies and gentlemen. But if you do this in your calculator, 2.15 plus 2.36 divided by 2, you will not get the correct answer out of your calculator. Your calculator will try to add this number, 2.15, to 2.36 divided by 2 if you do it this way. You have to put this in parentheses or hit enter and then do divided by 2, please. Okay? Again, it's just the way the calculator works. It's called order of operations. Your math teachers taught you all about this, but now you're actually putting it into practice, which makes it meaningful for you. Okay? All right. Please remember as well, these numbers are calories /G, calories per gram. Why is it important to do calories per gram? What? I know it is the unit, but why is it important to do that? To do it in calories per gram? Any idea?
Because it's all food, so it's a calorie.
Okay, then why not just do it in calories?
We don't see the big C.
And I'm agreeing with that. We get it into the big C, but why the big C calories per gram? Go ahead, Ethan.
I'm gonna guess because we do the calories per gram because it gives or shows us how many calories were burned.
Okay, but it's not actually showing you the calories burned. It's showing you the calories per gram. Let me ask you this. Which one has more calories in it? A steak or a macadamia nut? A 16-ounce tenderloin steak, an 8-ounce steak, or a macadamia nut?
Mistaken.
Why?
Because they had more
Let's just make it simple. Because it's bigger, it is going to have more calories in it. So can you compare the calories in a steak to the calories in a macadamia nut? Not unless you do it per gram. If you go to per gram, you could compare any foods. You could compare carrots to marshmallows and find out which one has more energy in it. But only if you get it per gram. Why? Because what are the chances of having a carrot and a marshmallow be exactly the same size?
No.
Not good. What are the chances if you burn them of them burning the exact same amount of mass so that you could compare them?
unlikely.
Not good. But by doing calories per gram, we are able to then say, okay, how does this food here compare with this one here? Because the size doesn't matter anymore. Per gram is a way of leveling the playing field, basically. Okay? That's why we put it into per gram, so that we can make a comparison between two foods. The chip, not as big as the marshmallow. Okay? One chip is not as big as the other. So even when you burn two different sized chips, you should have ended up with calories that were about the same, because the bigger chip should have burned more, but should have also released more energy. The littler chip burned less, released less energy, but when you go to calories per gram, they should be similar. Okay? That's the reason we do it, to be similar. All right. So here's the scoop, ladies and gentlemen. I'm going to give you 5 minutes to, with your partner, make sure you got everything you need done at the top. Make sure you've got your calculations done, or at least get as many of them started as you can. And in 5 minutes, we're going to go over the questions with you. Okay? If you're all done, good. Chill out, relax, talk with your partner. Today's topic is, did the primaries yesterday really matter when we all knew who the presidential candidates were going to be anyway? Talk amongst yourselves. Yes. Oh, how about we give you a title, a better topic closer to home? If you're done, talk amongst yourselves. Should Green Bay School District change its boundaries so that the schools are more equal in populations? In other words, Preble is not 2,000, we're not 1,200. Should we change the boundaries so that some Preble kids have to come to East?
Yes, I have friends at Preble.
Yeah, but it doesn't matter if you have friends at Preble. It matters where your friends live. It's not like they're gonna go, okay, who's Ethan's friend? You're coming to eat. No.
I was trying to figure out what was happening at the village yesterday, and I forgot about the primary.
What was Wisconsin yesterday? Somebody said there was something going on.
I mean, we had cars.
Yes.
On our street.
I know. I can't remember what they said was going on. I don't think it was the Wisconsin primary, but there was something going on where, because I heard there were school board candidates out there trumping for votes, trying to get their names out to people. So.
It's nasty.
Make a brown hard to sing it. Please don't make brown next time. It's kind of hard to sing it.
Okay, I will do my best. But it represents something burning.
I know, in like the top coat where we had like the number, in somehow.
Well, what I need to do is select white font.
It was like hard to read. Update because you have to like get close to the computer and read it.
But then I had to divide it that was like when you for this part or here. Yeah, like two.
One digit off. Would be 29. Okay, one middle is
The other one's yours. Did you do this? Oh.
That came back after like 40 minutes. It's just like there's you don't even do anything. That's how it's going. You move. That's how you do it. I got back. I said like 3 times. Then like after the 4th minute, I got you've been on the for an hour.
Uh-oh. They're looking for somebody.
or medium.
Mr. Brandon.
No, not all of them. So what you're gonna do?
Okay, thank you.
Is you're gonna.
Bye. Christopher, go down to attendance. Me? Yes. Yes, please.
That's all like last of the water. So here you
You had
All right, ladies and gentlemen. Again, if you do not have your calculations finished, you got to get them finished today and turned in. But we are going to take a look at the questions that go with this, ladies and gentlemen, so that you can finish that up and get that done and get that turned in as well. Okay? So the first question, ladies and gentlemen. State the law that allows for the basis of this experiment and explain the major assumptions we believe in this lab to allow the method used to collect the data and calculations we do in this lab. Now, there's a lot there. In general, how do we measure the energy given off by the food? Temperature of what?
What?
Temperature of water where? Just think about it. Where is the water that we are measuring the temperature of?
On top of the plate.
In the can, correct? Okay? So that energy needs to go from that burning food into the can, correct? Okay? In the earlier, when we were talking about kinetic and potential energy, we talked about how potential energy could be converted into kinetic if an object falls, right? Okay? And we said there was a law that governed it. Go back in your notes and find the law that governs energy going from one thing to another. Okay? Now, I do want you to think about this. For this to work properly, the energy from the burning food needs to go where?
Onto the water.
Which is where?
The can.
In the can where? Where's the can compared to the food?
On top of it.
On top of it. Okay? Have any of you ever been around a campfire?
Yes. Yeah.
Okay? Above the campfire, it is very hot. Is that the only place where it's hot?
No.
Because when energy is given off from an object, what direction does it go? Think about that. Think about that for this lab. We were able to collect the energy that went into the can, but did all of the energy go into the can? Or did some go off into areas that we did not or were not able to collect? Because that's what this question is about. Okay? We're hoping that the energy from the food goes into the can. But, as you just said, if you're sitting around a campfire, the energy from the fire goes in all directions. So what does that mean for this lab? What does that mean for the amount of energy we collected compared to the amount of energy we should have collected? Did we get it all? Why did we or why didn't we? You explain. Okay?
Textbook will move. Oh, yeah, you're done.
So make sure you tell me what law it is. And then again, the assumption is that the energy from the food ends up somewhere. Is that a safe assumption in this lab? Think about the campfire when you answer that. For number 2, ladies and gentlemen, we had this discussion a few minutes ago. Why is it important to take the calories burned and divide it by the grams of food burned? Steak versus macadamia nut, big chip versus little chip. Why do we have to take the calories and divide it by the grams of food burned? Go ahead and Give me your best answer there.
What? Oh. Right. Right. I was looking to the guy. Seen on your screen. Right.
Okay, that's one letter. The whole time they know. Oh, that's
All right. Question number 3, ladies and gentlemen. All you're doing is taking your average values for each food that you calculated from the lab and putting it in here. Now, I do not expect them to be the same as these. I do not. Okay? But in the end, you are going to have to compare this value with this one, this value with this one, this value with this one. So how does the calories per gram you calculated compare to the known value for each food? All you need to do is tell me for the marshmallows, our number was this compared to what we should have gotten. Our number was this compared to what we should have gotten for the chips, and our number was this compared to what we should have gotten for the macadamia nut. So you're just making a comparison there. Looking at the data you collected versus the data that you should have gotten. I am not grading you on how close these numbers are. I'm grading you on putting your numbers in here and then giving me a comparison between the two. And if your numbers were a lot smaller, a lot bigger, just tell me. But tell me for each of the 3 foods. And that is the last of the questions, ladies and gentlemen. So we're going to give you about 5 or so minutes here. Get them finished up. Get them turned into me. Okay? Get it finished. Get it done. Get it turned in before you leave today. If you have questions, raise your hand. I will be happy to come over and give you assistance. The only reason you shouldn't be able to turn this in right now is if for some reason your calculations are not quite done.
Can you double check my child too?
Hold on. I'm sorry?
Does that ever make you upset that you don't have Windows?
No. I don't mind. Hard to miss what you don't see. So on a nice sunny summer day, I don't even know about it in here. On a winter day that's snowing like heck, I don't know about it in here. So I've been doing it for 26 years. It doesn't bother me.
That can't be, Zoe.
Yeah, but that's a 9, so would that be
Punch it into your calculator again.
No, you only got round 1.
That's a good question.
Not minus, times. Divided by parentheses.
It looks
Why
I was like,
why
I've asked
two?
Sarah for help, and she's like, if it's a square, what do you
Times.
So long story short, each one
Mass.
has a
You didn't use the parentheses.
It was like,
There you go. That seems better. 99, 96 point
You
something.
know how to round?
Yeah.
So how would I run this number then?
What number?
That one.
What one?
Since that's a 9, would that make that a 1?
Why are you rounding it?
No.
How many digits are you trying to show me?
3.
Okay, then the 7 is the digit you're looking to round. And the number after the 7 is a 5.
Right.
So what do we do with that 7?
Put an 8.
And get rid of the 5.
Can we add these?
Okay, so you're not gonna round all the way over there because you still need to show that 6 and that 7 5. Put you round to an 8. Put a space in between them.
Because that's what they have made in
Well, you're going to. It's okay. You have different numbers than she does in there?
Yeah, like what? Okay, so wait.
And you're sure you've got the same numbers right now?
Yeah.
Are you on the same food? What food are you on? What food are you on? Are you sure? Go up.
I got 90-something.
Okay,
And then
so now, stop.
that is
Go up to the table up above and let's make sure you grab the right numbers from the table up above. Keep going up. Nope, stay where you are at.
make sure this.
Go back to where you were for the items and chips. Go all the way up, Victoria, to the table at the very top. No, you're not. We're not up to the one at the very top. Keep going, keep going, keep going, keep going. That's the one. I want 4 chips.
Like most you can do.
Is that chips?
Like,
So you got 117.345.
Oh, those ones.
19.970. Subtract those, that number looks correct. 27, 21, that number is correct. 61.958, 61.764, is that correct? I'm there.
And I just peeked you back.
Then this is correct, so if she doesn't have the same numbers you do, you have something wrong in yours.
So like,
Okay, so now show me how you do that calculation down at the bottom.
yeah.
We have to remember what we want.
That's all you need. So we were.
Calories per gram.
Yeah.
I mean, leave it because it's a nice description, but all you need is that it's smaller.
I would do divided by,
Okay, sorry.
but it's okay. You can do that, but I like to do this all as one calculation. And I'm gonna do divided by, take
So
the
why do
number
you
on the
put it
bottom,
over?
0.191
Okay, so why do you put it over calories over grams?
times 1,000.
How?
And I close your parentheses.
Okay, if we didn't do calories over
That's the
grams,
number that you should
how
have.
could we compare a steak to another?
How'd that compare to what you got?
Or
Victoria?
What?
But you can't do that if you don't have them all in
no,
the
we get
same
less.
units.
You got way
So
less
that's why you put
calories.
them in the same units, so you can compare them, no matter what their size is.
I don't know. All I know
So,
is
like,
you
maybe
guys should have
a
the same
nut
answers if
is
you're doing the same calculation.
3, like you
And the
guys.
numbers that she just punched in, we watched her punch in.
75.
So,
So which one would you assume is
What you're
bigger?
gonna do is you're gonna grab
Okay,
this
do you know
one
that for sure?
and then
nope, you're using the ones in the
Assume
yellow.
that because they're in the same unit.
The yellow is the mass of food burned.
Wait, you're gonna do this number times
No, not, you're not multiplying,
Compare
you're
different objects
subtracting.
of different sizes.
Over here, it says mass of food in the holder minus mass of food in the holder after burn.
Because you need them all.
You're
right.
subtracting those two numbers.
Yeah, you're minusing these two, but then you're gonna times this number. Because you get the grams of food.
But you need to go back all the way up to these two as well. This number here
Yeah.
times that number there.
It's gonna go with that.
No, then divided by that number. This number has nothing to do with the two up
Oh,
above.
I had to re-put it in.
Like your chips should not be.
I know that I had to re-put it in because as we calculated because
You would make that 3.11 because the 9 causes the 0 to become a 1. So that's 3.11.
I had to calculate that because I had to ask Mr.
Like-
Brandon.
Well, you should have.
You don't have to go after the second. You only need to do 3 digits. 3.10 0, but the 0 rounds up to a 1.
Take these.
Now, if you were to go 4, yes, the 8 would round the 9 up to a 10, and you would have 3.110.
Let me see your computer for a second.
Okay, but you can go with 3.11.
Something doesn't seem right.
And not 3.01, 3.11 calories per gram.
Because literally,
Okay, you guys are good?
the only one that teaches us
She is.
Yes,
You're good?
that's what I was
You're
told.
terrible.
I know the black eyes.
Good?
They just know that they put me on the center of bagel. Because the center is just such a teacher. This math.
I was like, who told you?
Not even Mr. Flimbuster doesn't even know what we're doing.
She's like, everybody told that.
Okay, it's not a good
And then she
indication of how much Sutter teaches.
sound like fun.
It is the way she teaches. None of us know what we're doing.
Really?
Yes.
So she fails all of her kids every trimester.
Well,
Every one
this
of them.
trimester, every kid
All
in
kids
my
fail.
class. In my class?
And you
yeah,
think
we're
we
failing.
would keep that teacher here if they failed every student that they taught?
Well, we're failing this because none of us know what we're doing.
Okay, so who's that on?
Not on me.
Your responsibility is to do your stuff.
I am doing myself, and this does not make sense.
So like, I need to.
Then you come to tutoring and I make it make sense.
Okay, that makes sense.
Why is Mr. Does not make sense.
One is,
Like, how you?
because my friend
How did the mass of the can be more than the mass of the water? And can.
Just if you see
No.
by year,
What's the matter? No. With that group.
That can't be. Yeah, I think you have a decimal incorrectly somewhere. The chips, mass of the can. What do you have for it?
Yeah. You've got,
I got it.
you've got your two numbers flipped.
No, I'm thinking they have an extra 1 somewhere.
Well, I don't know, because Kevin just went off and so I can't see.
Because the mass of the can and the mass of the can with water.
The mass of the can should be 16, not 100.
Yeah, not 116.
See, this is where you guys, you gotta be careful. You're writing down a number off a balance. You can't get it wrong.
And I
You
read
can't
it
get
was
it
20.
wrong.
All you had to do was enter them in the computer.
Done.
Now they see what you said and they're still.
Because she's right here. Are you done and is it turned in?
Yeah, slowly.
Okay, good.
Calculation go on.
Obviously. You've been done? Turned in?
What was yesterday?
Okay, how we doing? You got it?
Which I still wasn't on those.
16.
Just get rid of the first one.
Okay.
So,
Well, which is different than 4.6.
The 12.
So correct that.
oh,
But you
the
have this
112 would make
4.6 there
sense.
still.
So you're getting rid of the 1 on the 116.
Yeah, you're right.
It's supposed to be 4.6?
Yeah.
I thought you had 4.06, my bad.
Okay.
Done and
So
turned in?
the second trial is 14.
We do have one person in the country. The first one's giving us
Yeah, we could add,
Okay.
it would have beat all.
Go to the end of when we were talking about kinetic and potential energy.
Is the mass of the water also just kind of weird?
Well, look for it. Don't ask her. She doesn't have the slides memorized. You don't have them memorized.
The other one is
Why did you go off that? You
Well,
haven't found the answer yet.
But I don't know the question.
Well, where did I tell you to go? To where? I did. I said, go to the end of when we were talking about kinetic and potential energy.
Yeah, so you have to recalculate your mass of your water. So all you had to do is get rid of the
Go too
1
far.
and the 116. And it should be 16.313.
Still too far.
I'm trying to keep up as you were talking.
I have one right
Well,
here.
this is the end of what we were talking about kinetic and potential
Just give me a
energy.
second.
Yeah. So the question asks, which law do we use in this lab? Look at the title of that slide.
We're talking about
Yeah.
Lucy, are we done? A little question. Okay, well then you do it. Go ahead. Okay. Get a number.
like they know you do that.
No, I don't know how 1 can be 6 and 1 can be 0.3.
So which?
The chip. One trial is 6. Because I calculated it twice. So now I'm just trying to figure out what's wrong with trials.
Well, here's the thing. The biggest thing is you are dividing by much larger number than 2. So you've got the same mass of water, you've got a lesser change in temp. That's why you make it a smaller number. But the reason it's 0.3 is because this, you're dividing by almost 1. So there's nothing wrong with that calculation, it's just they're that far off.
Okay.
They're that far off.
You got a smaller tip.
It doesn't matter what size chip you are, because when you do it per gram, that should level the playing field.
Remember, our temperature wasn't going much without checking.
It shouldn't change much with a smaller chip, but you had an incredible change in mass for a smaller object. That doesn't make a whole lot of sense. Your change in mass of the one was 0.1. The change in mass of the second one was 9 times bigger. For a smaller object, that doesn't make any sense to me. So, all right, ladies and gentlemen, if you're not done, you need to get done. Okay? Today, though, we have been talking about food as an energy what? Source. That's how we get our energy. This is how you and I survive. If you were to stop taking in calories, ladies and gentlemen, you and I would simply die. Okay? Now, more important than food is we also need what? Water and air.
Oxygen.
Okay? Without air, you're going to die in minutes. Without water, you're going to die in hours. Maybe days. Without food, you're going to die in weeks. Okay? So, understand that while we need calories, your body also has a storage of calories in it, which we will get to talking about. So, in other words, your body could take and put away extra calories for you for later time. Now, why does your body have to store energy? Well, because you at times will use that energy, correct? Okay, if you didn't eat that day. Your body still uses energy. When does your body use energy?
All the time.
What do you mean all the time?
Like when you get from class to class or in gym class.
So in gym class, you use energy. Agreed. That's not all the time. You're not always in gym class.
Or going from class to class.
So when you're walking from class to class, you use energy. Okay? You're not always walking from class to class. What about when you're sitting in here? Are you? Yes or no? Are you burning calories right now?
Yeah,
Why?
because we're thinking.
So thinking burns calories?
Yeah, takes a pen.
Okay. Anything else?
So how about you go home, you sit there, you watch TV? Are you burning calories?
Yeah. You gotta stay warm.
Okay. So you burn calories to stay warm? Okay. You go to bed at night. You burn calories while you're sleeping. I'm getting a no, I'm getting a yes, I'm getting a yes. What calories do you burn while you're sleeping, Cal? Why do you burn calories while you're sleeping?
Well, your body like restores at night, I guess.
Restores what?
Like when you sleep, you know, I don't know, like you're like kind of like your back hurt one day, and like you'll sleep on it, and like you'll feel somewhat better.
Okay, I understand.
You know?
So your body uses energy for that? I'm just asking. Again, no, let's not
I
Google
did.
it.
I did.
Okay, Victoria?
So I googled it. The exact number of calories when you burn while sleeping depends on your age and weight. Generally speaking, sleepers burn between 8 to 40 calories an hour. So in 8-hour window, you can expect to burn between 320 to 640 calories per night.
Okay.
Well, you're burning calories all the time.
Why?
Your brain is active all the time, and your brain burns calories.
Your brain burns calories.
Yeah, because like daily functions, like just you sitting.
Such as?
Like even you just sitting here, standing still.
Yeah.
Your body, like even without you knowing, your brain still does a lot. And
Is it just your brain?
No.
What else has to happen? Even if you're sitting here, even if you are at home asleep at night, even if you are sitting in front of the TV just vegging out and watching it. What? What about your blood? So your heart has to pump your blood. Well, guess what? That takes energy. What else?
Oxygen.
Okay, you're blinking. So technically, I guess you're moving some at all times. Even if you're trying to sit perfectly still, your eyes are still going to blink, things like that. You're still going to move around a little bit. Alex, go ahead.
Your digestive system.
What if you haven't eaten?
Well, it still has to get energy from. That probably take energy too much.
Well, you're on the right track. You are absolutely correct. When you digest food to get the energy out, you need to put energy in to break the food down. Yeah. But okay, somebody would say, "Well, I haven't eaten in a day. So am I burning food when I sleep at night?" Well, no, probably not. You're not digesting it if there's nothing in your system. But what besides your heart has to keep working even while you're asleep? You mentioned the brain. You're absolutely correct.
Your lungs.
How about you got to breathe? How about you still got to breathe? So even when you're laying there at night in bed, not moving, sleeping, your body is still burning calories to keep itself alive. You have to take in oxygen. You have to exhale carbon dioxide. You have to pump blood through the body. Your brain is still functioning even while you are sleeping. Yes, there is not a moment of the day that goes by that you are not using energy, ladies and gentlemen. That you are not using energy. Now, when do you use more energy?
You're exercising. When you already ate something.
What?
When you already ate something.
Okay, doesn't have to do with eating something. Remember, eating something is energy going which way? In. We're now talking about energy going out. And you use energy all the time, even sleeping at night. Okay? Now, Victoria, you gave us this fancy definition out of Google just a minute ago, right? And what did it say about how many calories you burn while you're sleeping at night? Well, you should have read it better because you read something really cool.
You said what? I found it.
Okay, so what did it say about burning calories?
You can expect to burn between 320 to 640.
Whoa, that's a pretty big range, 320 to 640. Why would it be 320 to 640? That's like saying, I guess it's somewhere between 1 and a million.
No, it's So in an 8-hour window, you can expect to burn that.
Okay, so
But sleepers burn between 40 to 80 calories an hour.
why the big difference? I mean, why would one person burn double another person's calories?
Depends on their weight and their age.
Okay. What does age have to do with it?
Maybe you're older.
As you get older, your body, like your metabolism slows down.
Thank you. Key word there. We are going to keep things very simple in this class. What I mean by that is this is not a food nutrition science class. This is chemistry class. We're looking at energy in terms of when you take energy in, it comes from the foods you eat. Calories. We're looking as energy out is from the activities that you do. But what they are finding is that metabolism, when you eat, how often you eat, what kind of meals you eat, are they smaller meals more often? Are they bigger meals less often? Do you skip breakfast? Do you only eat one meal a day? Do you eat your meal right before you go to bed at night? All of those things affect your health and the energy that you take in. We're just going to keep it simple though. Every activity that you do burns a certain amount of energy. And you are right. Age is part of it because age affects your metabolism. Your metabolisms are a lot better than mine. Why? Because you're younger. Your bodies are still growing. Your bodies are still changing. Okay? Mine, not so much so. What other thing did you say had to do with it though, Victoria? Besides the age. Weight. Why does weight affect how many calories you burn?
Because someone could be lighter or heavier than you.
Okay. Basic physics, ladies and gentlemen. Alex, picking up this container of water and that one over there. Which one's more difficult? The one on the shelf over there versus this one. Why? So for you to move that, it's going to take more what? More energy. Well, I got news for you. The amount of energy that it takes Kiana to move her body is very different than the amount of energy it takes me to move mine. Why? Be nice. Thank you. Very nicely put. And yours is much what? Compared to mine. Go ahead.
Different?
How? Go ahead. Go ahead.
Just different. Weighed differently.
Okay. Who weighs more?
I don't want my fingers to sprain.
You got to point fingers. That's the reason that I picked you and me. Right. So for my body to move me takes more energy. For Kayana's body to move her takes less. Why? Because she's a lighter object. It's easier to move a lighter object. It is harder to move a heavier object. That's not your fault. That's just physics. Okay? Just physics. So when you do an exercise, okay, Brianna does an exercise and Alex does an exercise, who burns more calories if they do it for the exact same time? Why? Yes. Now there's the advantage I get. I go for a walk, Kayana goes with me, we walk around the school for Phi Ed class or whatever.
Like Miss Ferg does in the morning.
Okay? Who burns more calories?
You.
I do. Why? Heavier mass to move that distance means I'm going to burn more calories than you are. Why do you think when you get on a treadmill, when you get on a step machine, when you go to work out, what are the first couple questions that it asks you besides time and things like that? Your weight. Why? So that it can calculate how many calories you are burning. And it also asks your what? Your age. Why? Your maximum heart rate or your ideal heart rate is different than mine. I'm older. I shouldn't be working out as hard as you do. Okay? So those are things that affect it. Okay? Tomorrow, ladies and gentlemen, we're going to get into talking about energy out. Every activity you do causes it. Even sleeping causes it. Now, you know how we said that to compare a steak and a macadamia nut, we need the calories per gram? Well, to compare one activity to another, it's not only how strenuous the activity is, but it's also for how much time you do it for. So when you look at these, normally the calories in these, ladies and gentlemen, are going to be calories per minute. Okay? They're going to be calories per minute. And tomorrow we will take a look at that in class. Make sure your lab gets turned in by the end of the day today, ladies and gentlemen.
Mr. Brand, we only have 53 more days of school.
That's all?
Yeah.
It seems like forever.
Forever you're stuck with us.
Yep. I'm stuck with you.
Because I was like, hey, I wanted to do some weighted, so I was like trying to calculate this.
Well, there's a lot more to it than this. This is a very simplified version of it. Have a great day, ladies and gentlemen. Go away, get out, goodbye, go.
Zoe, go pack up your stuff. I'll give you
All right.
just a second.